Right. Hello, everyone. Welcome to the November 20th, 2024 meeting of sig-auth. Let's kick off, and we have quite a bit of agenda on our in the list. We'll start off with Micah. You have a demo to show us.
Yeah. I can take
You
over
want to
on,
share?
yeah, I can take over on the screen share.
Let me see how I can do that. Let
Send
me stop.
request.
Yes, there we go. Are you able to share now?
Let's see. Yes. Share. Cool. So I'm just gonna show off something I've been working on the last couple months now. So as a bit of background, so so Cedar is a open source authorization language authorization permanent language and engine by AWS. It is based on the original implementation is Rust. It's based on like SMT solvers, so satisfy a little modular theory. So it uses verification to prove that a policy is enforceable or not, and can apply to a given entity and resource. So to give you a really brief walkthrough of kind of what this looks like for Kubernetes, or well, even before what this looks like for Kubernetes, I'll give a little bit of the motivation first. So I started working on this just because one of the problems I encountered is when authoring and reviewing Kubernetes policies is that policies oftentimes in Kubernetes, you have an RBAC policy, which is an allow-only policy that applies to some set of resources. And then if you want to restrict that policy with either denials or more restricted behavior, you have to do that in another language, framework, and often policy file. What that can end up looking like, everyone here is probably familiar with RBAC, is you have like an RBAC role that might have API groups, resources, maybe verbs and some resource names or sub-resources or something. And then you might have another policy like this OPA gatekeeper example written in Rego that makes sure that some required label is there or something like that. And so it was while reviewing, for me, it was while reviewing these policy, like so many policy files of RBAC policies and not having the ability to restrict it further down. But then even if I wanted to restrict it further down, and I'd have to do it in a completely separate language. And reviewing the code diffs of these is a lot of effort, right? You have to know, okay, here's the allows in one file, here's the denies in this other file, and keeping all that in your head can be a lot. So I wanted to explore Cedar to see if I could get authorization, like access control in the same language for both authorization and admission. So I took a jump into Cedar to give you just a brief background kind of about what Cedar policy looks like. You basically get an effect, so a permit or a forbid. You can do explicit forbids, unlike RBAC. And then you just specify a principal access and a resource, or an action and a resource. So, and then an optional condition. So you can name a resource by a specific ID and action and principle like this. And then you can reference in conditions, you can reference a either a resource or a principle's attributes. So I can permit a principle in a specific group, and you can specify group, membership in either groups or in principles, actions, or resources. There's membership. So if membership, if that looks like the form of a group, I can say principles in a group, action is in a get or list set, and a resource is a certain type. I'm going to permit that when some attribute of the resource equals some value, but unless, which is just syntactic sugar for not having to put a bunch of exclamation points for nots, unless this other condition applies. So what that ends up looking like is for Kubernetes is I basically wrote some types around the Kubernetes API for authorization and for admission. So I can forbid a principal if it's a Kubernetes user on creating a config map when the principal, well, this is actually a messed up policy, but when the principal, it would be principal.name is test user. Cedar basically as a user of Cedar, you don't necessarily have to know this, but the way that it as a programming paradigm that it works is you give it a JSON list of entities. So you encode whatever structure you're evaluating as a principal and a resource as a in this Cedar entity structure, which has an ID, attributes, and possible parent types. Which parents are just referred to another entity in this entity list. So you give it this entity list. You evaluate when you do an authorization check. You say this is the entity type that's in this entity list, or the entity ID. This is the resource ID that I want to check on in this entity list, and here's the action I'm checking on. And so the Cedar engine can say, okay, given this entity list, I can tell you if this principal is authorized to do this action on a particular resource. To kind of help with like how to think about this, Cedar actually supports a schema, so you can validate your policies against a schema to say that to know ahead of time that yes, this policy is going to evaluate true or false. There's not going to be any errors. And for Kubernetes, I wrote a pretty straightforward, simple schema because every Kubernetes authorization request at the end of the day for an authorizing webhook is a subject access review, which contains a user or principal, and then a resource structure or non-resource URL, right? So the principles are pretty straightforward. When you have a subject access review, you have a user type, which is a user, which is a member of one or more groups. And so we can encode that in Cedar's constructs of group membership rather than have to just pass it as a list of strings. Users have a name and have key value extra info. And then I just made some special types for if the user name starts with system service account or system node. I just alternate, or not alternate, but I created a different user structure or principal structure. I'm not convicted that this is necessarily the best construct, but just wanted to try out this to see if it made sense. But I can encode the principal as a different type than just a user. Actions in Cedar are basically the same actions as you get in Kubernetes. They're just verbs. I just encode the verb. Every verb is an action type. So I can permit a principal and group viewers when an action's in a certain get list watch on a Kubernetes resource, unless the resource type is secrets in the core API group. It's just a kind of contrived example. And then the primary authorization resource types are non-resource URL. So when a Kubernetes non-resource URL comes through, I just throw the URL in there as the URL. And then for resource types, so everything else that you'd see in the typical RBAC policy, it looks very similar to you get an RBAC policy minus the verbs, right? So an API group, name, namespace, resource, sub-resource. I added support for the 131 field and label selectors. So we can do things like permit a group principal and group viewers, get list and watch on a resource unless it's a secret like we saw before. Permit group developer, principal and developers, get list, watch, create, update, delete. When apps and deployments, resources deployments in API group apps, and a resources namespace. So we're not going to do cluster scope collections request, but unless the namespace is kube public or kube system, say you wanted to prevent developers from accessing a specific namespace. So it's quite flexible in kind of what it allows. The other, well, let's go touching on the label selector. So here's kind of an example with that. So if I want to let a user list or watch resources that only match the label selector owner equals their name, I can do list watch, API group. In this case, it's just a config map, but API group is empty. Resources config maps. The resource must have a label selector, and the label selector can be owner single equals principal.name, double equals, or owner is in some set of principal.name. So this is this ends up working as a way to constrict restrict what kind of requests a user can make around label selection. So I do have a test cluster here, but if I'm a test user and I want to try and get secrets, I can actually try to share this out. Let me clear this. So test user can't get secrets, but if I want test user to get secrets where owner equals their name, they can see that one secret is there. Show labels, and you can see owner is test user. So if I go back to that same user, who am I? You can see that my name is test user. So this is just kind of illustrating that. I do have the one difference besides non-resource URLs and resource URLs is impersonate verb. So for impersonation, I basically just encode the resource you're trying to impersonate, whether that's a group user, a UID, or key value extra, as that resource. So we can write policies like principals and group actors, and action is impersonate. Then they can permit to impersonate group superhero. Same for user or UID, or key value extra. Was there a question? I'm sharing my screen. I saw something in the chat.
Hey, Micah, I had a couple questions, but they're not, don't interrupt it. They're just sort of residuals.
Okay. So that's kind of just the brief authorization overview. I'll jump just on the admission part too. So this is kind of to that earlier point of like wanting wanting to be able to have authorization and admission in the same in the same policy file. So I also encoded basically I wrote a converter for the Kube Open API schema to the Cedar schema format. I can actually give you a really quick view of what a Cedar schema looks like. So here's the authorization schema. You basically have a namespace and types, and then you can encode all your embeddable types as type, and then entity as the actors or principals. And then in your actions, you can specify which principles apply to that action and which resources do. So for an impersonate action, it can be a group, node, service counter, user can be the principal, but then the resources are not non-resource URL and resource, but extra node, principal UID, service account, user. So you can run this schema against your policy to check that your policy is validly written. For the admission schema, as I mentioned, I wrote an Open API converter to Cedar schema translator, and just for the entry types, generate and store the Cedar schema here. The admission actions are much less. Obviously, it's just in mutations. Connect, create, delete, update. But the types here are basically from the Open API type. So you might have like namespace for v1, and it has all these embeddable types, and then the entities are, scroll down far enough, we'll get to entities. So pod exec options is one. That's more on connect. Entity is pod, right? Things with basically a type meta and GDK. Getting back to the admission really quick. So yeah, so for the admission schema, yeah, the actions are just the connect, update, delete, and create. And so we can write things like forbid a principal in where the action is create or update. from acting on a kube resource pod when the resource has host network and host network is set to true, unless maybe it's kube system. Trying to think what else I wanted to say about that. I think that's most of it. The one other example I just wanted to show really quick is probably just around like label-based access control. So like oftentimes you might, a common example I think that Kubernetes RBAC doesn't support today that you might want to enforce is that a user can only touch things with a certain label pair. And it might even be across namespaces. This sort of can allow you to divide a cluster in ways other than a namespace. Obviously, namespaces have their place and they do divide things in a certain way. But if I wrote a policy like this, an authorization policy that lets a user create, list, watch, update, patch, and delete on Kubernetes resources, in this case, I'm restricting it to config maps in the core API namespace and in default name or core API group in the default namespace for just the sample user. But I want to restrict it more. So I want to forbid them from listening and watching unless they have a label selector in their request on those lists and watches. And that label selector has owner equals principal name, like we saw in that sort of earlier illustrative example. Same, and so that's still an authorization policy. For now, for an admission policy, I might want not just for get or list and watch, but I might want to prevent, create, update, and delete unless the resource already has the owner's principal name. So I can do that here. And similarly for update, I don't want them to overwrite a resource that doesn't have the label pair already. So I sort of inject an old object attribute on every admission type that is just the same type as the type itself, so that we can check if that old resources label pairs also have owner as principal. So really quick example of that is like, I can say I'm a sample user. If I want to try and create a config map without a label pair, oh, okay, I broke my cluster. That shouldn't have worked. But let me see, okay. Well, I broke it, but the sample user, basically, if they try to get a config map, this should deny because, okay. And then it tells me which policy denied the request. That's on the authorization. And if I try to label a config map, it's also going to work. Yeah, I just blew my cluster away and recreated it right before this. So I did not double check all this. But I do know it totally works if I reread and refollow my instructions. But if I do end up creating a config map where I set the labels on creation, it will work. Couple other things to call out. I think where I want to go with this, I think there's some things to figure out. There's a few limitations to call out. I'll call out limitations first. Kubernetes has sort of implicit denials on sub-resources unless you name them. Cedar doesn't. It's sort of implicitly allowed on sub-resources unless you deny them or specify you don't want them. So for the above Kubernetes example of get and list on services, that does not include get on port forward. If you do a get and list on services like this seems like it should be the same as the first policy, but because a port forward has a get verb, that would be allowed. So I'd have to do a policy that says unless resource has sub resource, which port forward is a sub resource. There's Cedar just added support in the Rust variation for key value maps, and it's not made it to the Go version that I'm building on. That's pure Go. So that's not there yet. That's coming. The kind of the first question folks ask is like, is this a replacement for OPA, Caverno? Like, how does this compare? Cedar, it's not. I don't view it as a replacement for Caverno or or OPA or validating admission policy, because there's a lot of things that Cedar cannot analyze using automated reasoning. It does not have ordered maps or ordered lists. It uses unordered sets. So when I check for set presence, it's not an ordered list. It doesn't have a map or apply function, so I can't do a check of every container in a pod to check that the image comes from a specific registry or that the resource limits are set or something like that. I can do set presence on a list of labels, but I can't do I can't do those nested fields on sets of structures. There's just other sort of functionality, like you can't call a size function on a list or a map, just because that's not really possible within SMT Solver. So one of the other issues here is that I'm probably most interested in talking here in API Machiner about is like policy store updates and race conditions. Like if the policy store updates in between authorization and admission, that's really bad if you have an allow in authorization and a deny in permit, and then both get dropped in the middle. Now the authorization was permitted with an unrestricted admission. There's no permission enumeration. There's some support for partial authorization in Cedar, but not in the Go version yet. But yeah, obviously, Kubernetes auth Z webhooks don't support permission enumeration either, and there's not really support for privilege escalation prevention here yet. RBAC has its escalate and bind verbs, but this kind of goes hand in hand with the enumeration limitation. I could probably do some form of like checking if a user grants themselves any new permissions. That can probably be checked, but it's difficult about like granting someone else more permissions. I think other places I'd go with this, probably I'd like to add multiple sort of tiered policy supports, because you can do a forbid. You can basically forbid everything, forbid principal action resource, which sort of breaks your cluster from like working at all. So I probably will be adding like support for like a tier 0 that might have like all the RBAC policies or the controller type RBAC policies converted. I wrote an RBAC converter, so that service accounts, keep controller, manager, scheduler, etc., can all work. And then any explicit permits would be evaluated and returned before even looking at another policy store or another tier of policy stores, so that if someone wrote an errant policy store or policy like this, it wouldn't like break the whole cluster. Other things that I want to add are like support for cluster metadata. So this is an EKS example, but you can imagine like lots of other sort of cluster metadata schemes where you might want policies to apply across multiple clusters, and you could sync them via some external policy store. And if you injected cluster metadata into your evaluation, you can write a policy that says, forbid updating pods when the cluster has tag stage, and stage is prod, and the pod has ephemeral containers. So again, it's really more about access control than like resource sort of pod standards, but there is some like I can check for presence. Like I would deny ephemeral containers. Yeah, I think that's most of it. I know we have a full schedule, but I want to leave time for any questions.
You have some questions in the chat, I think.
Yeah. Ollie, what was your question? Encode Cedar, Kate's resource type is Cedar attribute.
Yeah, I have a couple questions, Mike. I think you've already answered the first one. I was under the impression at the beginning of the talk that all resource types, all Kubernetes resource types are modeled as one entity type in Cedar, and I don't think that's the case. You did show us that list of.
Yeah, that's true for authorization, but not for admission. It's a different action and different namespace for admission.
So it is the case for authorization, but it isn't
right.
for admission. Let me write that down.
Yeah.
And the follow-up from there, I suppose, is have you given any thought to modeling parentage? Say pods to replica sets to deployments.
No, so no, because well, I've thought about it a little. So right now I'm not presenting in the entity list anything that's outside of the subject access review or the admission review. So if I wanted to go look up like pod is in namespace and put like namespace with its labels or something in the entity list and represent pod in name, like the namespace as a parent of the pod, or as you mentioned, like replica set for a pod or whatever, right? Or job. Like I would have to go look up that external type and then inject it in the entity list. And I'm not doing any like lookups. I'm keeping it really simple and dumb for now.
Gotcha.
It's
Okay.
possible. It just is not. It's not something I've done.
Right. It is very much possible. I mean, that's what we're trying to build out on our side of the pond here at Strong DM, is to have a cedar. We call it the cedar verse, but to have a representation of everything inside a cluster inside the cedar entity. Let's call it map.
Yeah.
And it unlocks that kind of use case where I want to say, hey, I want to restrict things so that everything in this deployment has the same rule on it. Okay, so I have the answer is it's possible, you think it's possible, but it's not in this today.
Yeah, it's like it's definitely possible. It's just not something I for simplicity reasons that I've like avoided doing, just because I'm kind of afraid of like caches getting out of date and like making bad decisions.
Right.
Preferring to say, okay, for the simple things that like, yeah, like anything that you're kind of referring to, like, so pod, like a pod's namespace or something, like that's in the type meta. Any owner refs are going to be in the owner refs. So you could check his owner ref with this name part of the owner ref set or something. So
Right.
some of that would be look like addressable, but it's not like I can query the full graph easily with Cedar.
Gotcha. Great, thank you.
I had a question related to pulling the schema out for all the objects. You said you pulled out the schema for all the objects. I think I saw that used down in admission to say like, hey, I want to inspect this particular item. I wondered how that played with CRDs and how that plays in particular with CRDs that contain something, or built-in types, I guess, that contain something like a raw extension, like a DRA.
Yeah, good question. So I have sort of like papered over that problem for now by it does support like analyzing CRDs. I basically ignore raw extensions for now. Yeah, I'm trying to think what else.
So
Yeah,
the
go ahead.
case doesn't worry me too much, but the remove case seems interesting to me, right? Like, so you imagine, well, the Gateway API people talked about adding a field, and then later they want to remove the field. Where does that leave a policy that refers to a field that no longer exists?
That's a good question I haven't thought about.
Okay.
Yeah, I'll definitely think about that one. Your other question about just CRDs too is like the schema is more for like reference support for now. I think like if I wanted, so a couple things is that the Go version of Cedar, the Go library, does not support schema validation today. The Rust version does. If I wanted to actually validate like all policies against a schema, the tricky part with that is that obviously from one cluster to another, the same CRD, even a API version group type, can be different. right? Like I can write the same CRD version in my cluster that you write in yours, and they can be completely different shapes. And so if I wanted to have that, validation done, I'd have to like, for the entry types, that's fairly static. But for the like CRD types, I basically need to like generate it per cluster in the like webhook and then keep it up to date. Yeah, I can wrap up. Keep it up to date based on any CRD changes for those CRD types.
Okay. I wasn't trying to like force you into an embarrassing conversation. It was just I didn't understand the repercussions.
Yeah, yeah.
That's fair. So thank you.
Okay. Any other questions for Micah? If not, then let's head back to the agenda. Let me share my screen again. All right. Can you guys see? All right. So we have her. Okay.
Yeah. And I see I've got a lot in a row, so I'm happy to like switch off with like interleave people who are below on the agenda. So the first one, and I think I looked back to the meeting notes and we discussed this a couple months ago, but there was no like actual conclusion recorded in the notes. Um, so I don't remember what the context of the discussion was. Uh, Basically, we're in GK, we're building an authenticating proxy, and it would very much simplify our life if the authenticating proxy had the ability to say like, hey, the user I just authenticated is, system colon service account colon foo colon bar, but also it should be bound to pod X. So like this request is only valid if pod X is still running. Similar to the way we can bind a pod or a service account and a node um, in a service account token, it would be great if we could have some headers that would let us express those bindings for an authenticating proxy. Um, how do people feel about that? And I mean, obviously, this would require a KEP. So, um, David, I guess.
Yeah, I have a question. So in thinking about this, how would there be limits on what sorts of object bindings are allowed? Or like as a for instance, I'm a user and I have access to namespace A, but I desperately want to know if namespace B exists. And so I start issuing requests that say only allow this if namespace people I'm going to fire in 2025 exists. How
Well,
would
I
that
think we
be?
kind of sidestepped that problem with the authenticating proxy, right? We require you to present a client CERN signed by a super special CA. That
So this
Guess
is
I'm
a
not clear
this
on
is
how.
an authenticating proxy header, not a general purpose header. This is a header that only impacts the request header authentication.
Right? I guess I'm not clear on how that would be different, right? So you have a request header, there's a user that has rights in one namespace, gets terminated by this proxy, and are you saying the proxy controls it and the user does not, and thus that's how that would be enforced?
Yeah, I would think the proxy would have to definitely like not let a user try to pass this header
You have
through.
to
This
strip
would be
it.
something that only the proxy could set.
Okay, thanks.
I don't know if silence is don't care, send a cap,
Oh.
or
would we be able to use the same extra value keys that would map to that the pod bound service account token creates? Like, would we enforce that only those values are accepted?
I'm sorry, I don't quite understand what you're asking, Abhijit.
Like, if you have a service account token, you get some extra values, right? Like when you authenticate, the authenticated user structure contains pod.uid, pod.namespace values. So,
Okay.
yeah, because allowing the authenticating proxy to set this would let it kind of extend the binding mechanism. Like you would have two different versions, two different user extra headers. That some could come from the authenticating proxy headers, and the others could come from real service account tokens. And if they are being set and verified separately from each other, that would lead to like downstream users not being able to figure out like which one to trust.
Yeah, that's a good question, whether you'd want to leave it up to the proxy to set the bound object headers in extra info itself. So requested check.
It has the capability to do that today, right? You can pass arbitrary extra user info headers.
It's probably not a great idea to delegate that when kube should be the authority. Those specific extra info parameters.
Yeah, I think I've just been thinking about it from the security perspective of allowing Cube API Server to enforce the binding checks, because Cube API Server is well positioned to do that.
Yeah,
I guess
right. That's the most
hash out in the KEP whether or not that should automatically, like, I think I could go either way about automatically adding stuff to user info extra.
Yeah.
like third-party advisors looking at that should be able to like make sure know that if the certain header exists, the extra header exists, like a pod UID exists, then it has validated. Right.
It's also a question of what does the binding mean, right? Like in this case, like so in the traditional case, the binding is in the token that was issued to the specific thing and has a semantic from being in the token. In this case, allowing a proxy to receive any token from anything, it could be Kubernetes, it could be some other system, and just decide that now on the back end, this request is bound, some object exists. If you also automatically forward the claims effectively to user extra info, you're sort of implicitly adopting this semantic that already exists. It may not, in fact, be true in the proxy case.
Yeah, right now the proxy has total authority over all of the user info. And so the API server, the proxy is super trusted, mutual TLS. API server just takes its word for whatever it says about the user. And that has the nice property of it being totally opaque from Cube API server side. It's sort of the ultimate Swiss Army knife of flexibility. This would be like adding semantics to things. So I'm pretty hesitant to like mix doing that implicitly based on extra things the proxy was setting.
Like if the proxy wants it, it can set it, right?
Yeah. If it is fronting the server and interpreting credentials like service account tokens that are expected to translate into particular shaped users with user extra info, making sure the proxy never ever skews and always translates into exactly the same user extra info that Kubernetes would natively is super important, because that is user facing. That's effectively an API service that people write validating emission policy against and all kinds of things.
I guess it could be an option when you request the checks. You can ask QAPI server to add those, but you don't have to.
David, you still have your hand up. Is that
Yeah. So I guess the other thing that I would then wonder, right, if we're not going to allow a user to pass this through, which makes sense, why can't the why is the QAPI server better positioned than the front proxy to do the get and see if it's still there?
Assume it's
because
because
QAPI server has it already loaded in memory. It's already got
it's
all
cached.
the.
Maybe I'm unaware of it, but I didn't think that the QAPI server already cached every type. There are some that it does, but I didn't think that it did all of them.
It does.
Where is that other than the watch cache?
Node authorizer and service account authorizer have informers for service
Those are
accounts.
specific. So are you saying there's some types you're interested in, or is this an arbitrary? It just doesn't say here. Like,
I would say what we're
I
interested
read this
in
as
is,
requesting specific ones for service account token
yeah,
bound.
like whatever bindings are expressed in a service account token, we would like the ability to say, this user is this user, but only if this pod exists
okay.
or
So
this service account
specifically
exists.
pods, right? So not just general. It wasn't clear this is only pods.
Okay, yeah.
Okay.
Let me write that down.
Yeah, we're interested also in this remaining compatible with future extensions to service accounts. So if we ever add other object bindings than pod or node, then this mechanism would still have to support that extension.
I think you can bind to a secret, right, as well. Not that.
Not
like, use
sure.
I think
Yes, you
the
can bind
details there
to a secret.
matter because some things are cached and some things are not.
And to answer maybe your other implicit question, David, it is totally valid, and we could implement it by, before we forward the request on, we first make a get to Cube API server, maybe through some cache, and check the object binding for ourselves. But we're worried about like write amplification, or not write amplification, but just the general amplification there.
Wouldn't that be the same either way?
Not in terms of the number of inbound network calls that Cube API server is handling.
Well, but if you do it through a cache, you want to tolerate the cache anyway. Then you would be saving yourself.
I think the bigger concern for us is probably maintaining compatibility over time with whatever Cube API server chooses to implement.
So then if it's okay.
Like
I
we
feel
just
like
want
that seems like it would be an issue regardless, as like tight compatibility with every new claim and every new user extra info and whatever validation is. Like the validation bound object validation is one aspect, but all the claims and all the translations to user extra info are
Yeah, I think that's
squarely-
pretty firmly the responsibility of the person who has decided, or the company that has decided to run it.
Right, but like the same attention that has to be paid to keep that compatibility.
Yeah.
It's like, here's the claims, here's the user extra info, here's the validations. It seems like
so reduces it a bit, right? It's like the map. Okay, this is a node binding. This is what we expect. Yeah, I mean, sure, you can give your proxy all that. Just a bit less.
So the actual request here then, if I'm understanding, is not, hey, I want to be able to indicate that this particular object exists. What you actually want to do is create a user extra that is the same shape as a service account and then have the QAPI server enforce the user extra as if it was a service account?
Yeah, I mean, I guess you could almost take an alternative view of this. Say it would be interesting if a authenticating proxy could authenticate an inbound token and then tell Kube API server, hey, I've authenticated this token, but you should do all the same things with it that you would do with a normal token, even though you can't.
I guess I don't understand why use request header auth at all at that point. Why not just forward the request with the token?
Yeah, I'd say we're agnostic to the, like, maybe in the interest of the time here, we're agnostic to the mechanism, I think, whether that is an explicit header that says enforce this binding, or maybe some sort of magic where we add extra user info headers and then Kube API server thinks about them real hard.
Maybe this becomes more relevant with something like pod certificates, where you have a non-forwardable credential.
Yeah.
Sure, that's another good example.
I think so. Maybe. So I guess maybe where yes, maybe where it's non-forwardable, it matters. I guess what I'm struggling with here is like you have a goal, and I think I kind of get it, but I'm not completely sure that it's actually easier than the alternative that exists today for either of us. Like for the person creating the authenticating front proxy, it's kind of ideal to know, like, I know whether this thing was allowed or not, so I will tell you, versus let me be sure that I've got it right at the other end as well. And then on the API server side, it's not clear that it's easier to implement this logic than simply accept what we have today. And I guess I'm not quite seeing it yet.
Let me ask maybe a different question. Would it make sense when a proxy adds the equivalent user extra info that would be applied had an object binding been checked on a KSA token by Kube API server, if Kube API server will verify that that user extra info is still valid in terms of the typical object bindings that would be associated with it?
I would struggle to understand why the request front proxy was special. And knowing the code path, it is not immediately obvious to me that it is trivial to do.
Okay.
That's not like an impossible forever, but that would be, I think, a significant change to our semantics for user extra today.
Okay, yeah, just thinking of it in terms of like consistently enforcing that object binding semantic, no matter who sets, sort of determines.
No matter who sets it. So global shift, I'm still not sure that it would be a good idea, but at least it would be consistent.
Right.
Then I think I would again be worried about the hunting, right? For I'm going to fire David in 2025 namespace.
I'm not sure I followed that.
I think let's maybe take it back and evaluate whether or not this get through a cache or informer, like what the actual traffic implication of that is for Kube API server. I think given that we are interested in writing this front proxy that is doing this, I think like just the technical complexity of writing the object binding check is not that much. Like we're already committing to keep compatibility across a large surface that we'll have to continually staff. I would think the only reason why we would want this mechanism is if there's some sort of big efficiency gain to be had in Kube API server handling the check, which it sounds like maybe there's not.
I don't think I see it. I mean, cache seems like a cache. But either way, the semantic behavior is at least
for some context, that this is for multi-tenancy. So like the hit ratio may end up being low, but we have to evaluate that.
Yeah.
Okay. I think
We should, yeah, we can look at like Kube API service cache is a bit special, right?
I don't think so. It's just a
Not-
more fed cache.
How do we, I guess, how do we populate the, okay, I guess it's always just after, right, to etcd that we populate the cache. No fancy magic going on there.
I can't remember. It might be a getter interface that checks the informer cache, and if there's a miss, it might try a live lookup. I can't remember. But the cache itself is just an informer cache.
My apologies for potentially an ignorant question, but so if I'm understanding right, this is on the network path for requests then for this proxy, correct?
Yes.
And if regardless of the cache, unless that cache is really perfect, there is a kind of a significant risk of denial servicing an etcd with that, right? Because all I need to do is try to be able to find a way to generate requests that I know aren't cached and are going to generate etcd requests and then throw traffic until that etcd falls over.
Yeah.
This is post a valid signature check. So
Okay, cool.
like it has to be a token that was actually issued. So a random attacker doesn't get to do this. But yeah, a token that was valid at one point and then the relevant objects got deleted. Yeah, you could probably do this. But this was someone who actually was authenticated at one point and presumably could just do lookups as well.
Yeah, I wasn't necessarily thinking quite as malicious as a true attacker, as much as just is it a really hard to configure feature to avoid foot cutting yourself as an admin too.
Kind of neat that you would be able to do an impersonation to impersonate the user extra fields that indicate which node you were bound to and not have those checked.
Right.
that's
weird.
off proxies for you.
Weird. So like the auth proxy being able to say, hey, could you like just double check that I got this right? Not necessarily a bad thing, right? From a defensive standpoint.
That was just
I just want to read this time check this, so we want to hit something else.
I would like to talk about the tokens bound to certificates. Is that specific to service account tokens, or is that actually any OIDC token?
That is.
It will be okay if we don't.
Yeah, except for. Oh, sorry, Abhijit. You got a lot of background noise. I hadn't thought that far. We've been discussing this a little bit on the Google side, not in the context of Kubernetes tokens, but there are some cases where it would be really nice. Like we have some intermediary tokens where they can be cert bound or even network bound, although that seems like a harder problem to solve at the Kubernetes layer. And it would improve the security model if we could make service account tokens or any token that Kubernetes understand, like have Kubernetes issue tokens that contain these confirmation claims and also maybe understand them.
I only skimmed the RFC. It was a new one for me, but the idea of having a certificate bound token for any OIDC token, not just service accounts, sounds pretty interesting to me.
Yeah, the way it works is the JOT embeds a new confirmation claim, CNF, because JOT pays by the letter, I guess. And in that you can embed a couple different things, but the only one that seems really truly spec'd out is embedding the SHA-256 fingerprint of a certificate. And then during authentication, whoever is checking this just checks that the leaf certificate that the client presented matches that fingerprint. Otherwise, the token is invalid.
And it has to match the TLS certificate that was used to make that connection. So,
yeah.
I would be interested in seeing at least enough of a KEP to see what it would take to develop this, right? Because I think it would require some changes to the current authentication stack to sort of link together the certificate and the token flows, which, if I recall correctly today, are distinct, and certificate comes first.
I think the way this typically works is that you do whatever TLS client validation. Well, I don't know. Yeah, it may require changes in the certificate.
My memory is that when we wire this up, if we already have an identity, well, one comes first and one comes later. Maybe the token wins. We have two separate authenticators today, and understanding what it would take to actually do this and not break ourselves.
yeah, it would all. I tried doing this some time ago with a slightly different RFC called Depop, which doesn't require knowledge of the TLS connection. So in that case, like you would, the first problem I ran into was that the native clients will not send a token if there's already a certificate present, or vice versa. So, and also
what was the RFC? Depop?
Depop are demonstrating proof of possession. So the downside with this MTLS bound token is that you cannot. So if there's let's say there's like a front proxy, right? Like a HTTP proxy, and that terminates the TLS, like there is no standardized way to tell the Cube API server what certificate was used to present, was used to connect to the front proxy.
Sounds like another
there are non-standard ways,
proxy header.
That would also be another thing that would need to be worked out to make this work. Whereas Depop signs the request parameters with the private key, with a private key that is bound to the token.
Okay. Well, thank you all for the lively discussion. Everything is recorded, and let's follow up on a KEP. Thank you, everyone, and have a great day.
Thank you.